Okay, so what we're looking at here is reducing balance loans. And look, I'll be going through the theory here, and then over a number of different mixes, I'll go through some worked examples. So I'll go through a bunch of in this video, then I'll make some more some subsequent ones after that. Okay, so we're looking at, like I said, reducing balance loans, which are basically compound interest loans with periodic repayments. So basically, we use something called the annuities formula, and that can be used to find the amount still owing at any point during the time of a reducing balance loan or investment. Take note, an annuity is a regular payment, okay? And the idea of reducing balance loans is that what happens is interest is charged every month by, say your bank, your financial institution, and you make repayments to the bank on a regular basis. And generally the idea is the repayments will all generally be more than interest. So over time, you're paying off the interest because you've borrowed money from the bank and they want to make some money, but you're actually also paying off your principal. So how much you owe decreases. And so your interest is constantly being calculated based on your current balance. And it's sort of that process where you take off you're going to pay money and then you take the interest in that, but some of that money will come off your loan. Okay, so that's the idea of what we're talking about as a reducing balance loan. Okay, so when a consumer borrows money from a financial institution, the person contracts to make regular payments or annuities in order to repay the sum borrowed over time. So what it basically ends up happening is that, when you've borrowed 10 grand, you're going to be paying more than 10 grand overall, but you get to get that 10 grand to buy your first car or something like that. Okay. So when we're talking about reducing balance loans, the idea is it's got this sort of shape to it, where this is where you've your amount owing, and over time that sort of decreases. But you can see it's not so linear. It takes a while. That first phase takes, you're paying. You still own a lot over time, but once you get past paying that interest off, it speeds up quite quickly, but the interest takes a while to come off. So you got your principal, is your V0. That's how much money you've borrowed, and the balance is how much you owe. That's your VN. So if you think back to when we did recurrent stuff, the V0 is, the V0 is basically your previous term, and your VN is your next term. That's your sort of what we're looking at here. The term is the life of the loan in years, and to discharge a loan, so to discharge a loan means you've paid it off. That means your VN is now 0. So if it says how long it's taken to pay off your loan or discharge your loan, it means when VN equals 0. Okay. Here's the recurrence relationship. So you need to, I'd say put this in your book, summary book for sure, because, as in any of these, you need to be able to show, put relationship there, I mean to put summary book, okay, summary book, okay, put this into your summary book. Because it's useful to have this, because it sometimes the questions might ask you to write the recurrence relation for whatever the problem is. You need to be able to refer to the recurrence relation. This corresponds to this sort of table here, and we'll go through a work example of that in a little bit. Okay, we've got something called the annuities formula. Okay, the annuities formula can be used to find the amounts due owing at any point during the term of a reducing balance loan. So as you've got here, you've got your VN, your amount owing after N repayments, N the number of repayments. So remember, if it's 2 years with monthly repayments, that's 24 repayments. The amount of the regular repayments made per period. So are you paying $500 per payment or $200? That's what this is talking about. It's the regular repayments. R is a compounding a growth factor. So remember, that's where we've done, it's represented by 1 plus R over 100, and it's the rate per interest period. This is where, I sort of skip past this, sorry, is where you convert into percentages. The interest rate per period, so for 6% per annum compounded monthly, that's 6 divided by 12, okay? That's what you need to do. So this is where, if it's 7.5% compounded monthly, 7.5 divided by 12, okay? But it becomes 1, so that's this little bit. That's what I should have said. But that's what you need to calculate there. And that becomes 1 plus whatever that value is divided by 100. All right. Now, this equation, and I'm going to do some questions using this equation. This equation looks confusing, okay? Just because it's lots of things. It's easy enough to do. If you're putting this into your calculator, you just need to be very, very careful that you got everything in the right. That's what I mean when it looks confusing. There's lots of letters and numbers and stuff, but you just need to make sure everything's done properly. Alternatively, for most of these things, you can use Finance Solver. So for some of these, I'll show you how to do it using the equation, but to be honest, it's just as easy to use your Finance Solver, but you need to be able to set this up knowing what's occurring here, okay? But Finance Solver is always quite useful. So what do we put in our summary book? This, I would put summary book, that too as well, those two in there. This you'll need potentially later on. Again, you can get D, which is your installments, which is also another word for repayments, from your Finance Solver, but I would put the formula in your summary book anyway, so you've got access to it. You don't have to sort of transpose anything yourself. It's there ready to go. Now, I would probably put, if you can't remember how to get this up, I'd put this into your summary book. Okay, because it's useful, because you might just use a lot of these ones you need to use, calculate instructions especially in exams. You need to be able to find this quite easily. Put this in there just so you've got a record of it. I'm going to go through this now, but I'd also put this in your summary book. Okay. But I'll go through each part, but what the key point here, the key point is this. If the bank gives you money, the number you will get, or what it implies, or what you've got to put in, is positive. Okay. So you got to think the money's going into your bank, so it's positive. If you give the bank money, it's the number you have to put in is a negative number, because it's leaving your bank account, so it's a negative number. So when it's a loan, so when it's a loan type situation where you're borrowing money, your principal value is, remember, principal value in our case is your V0. It's going to be a positive number. That's where the bank lends you money. The payment, which is also installment. Okay, I'm going to get rid of that. I've written it there, but I'm going to get rid of that now because it's too hard to read. That's going to be negative because you're giving money to the bank. Your final value is either going to be 0, loan paid off, okay, or it's going to be negative because you're still giving the bank money. So at the end of the loan, it is either going to be it's either fully paid out, or you still have to pay money to the bank. So you're still paying money, so hence it's going to be a negative value. If it's an annuity where you're like you've put money in, because you want to earn some money from it, the principal value is going to be negative. So because you're giving money to the bank, the payment's going to be positive because you're paying money So you're going to get regular payments back from the bank. So that's going to be a positive number. The final value when the money runs out would be 0. At the end of the annuity, there is no money left, or the bank pays you back what is left, hence the positive part. Then you've got investment that is added to on a regular basis. And same process goes through there. Now, there's also another one, and it's in the OneNote. I'm going to sort of show you what it is. This, I would also, the one I just showed before is a nice for just what we've looked at, but this one incorporates a compound interest, perpetuities, annuity loans, stuff, any superannuation type questions, reducing balance depreciation. And where do you find it? On the OneNote. I'll try to get it to show. It's in Finance Solver Summary, that part there. Okay, that's where you need to go. Oops, sorry about that. I'm going to pause. Oh, well, I'm going to have to work this out myself. I'm not doing a very good job. All right, so let's go back. Sorry about that. You can skip through that part quickly. All right, that's sort of the theory, okay, for annuities. So what I actually might do for this is stop the theory there, because I don't want to keep the clips for too long. And then I'll do separate videos for each of the set of worked examples that I'm going to go through. Okay, so that's your basic theory for reducing balance loans, and that's what you have. This is the sort of stuff that we'll be referring to throughout this part of the topic. And I've actually made a video on how to use Financial Solver already in terms of compound interest, so you're sort of familiar with this as well. Okay, so I'm going to stop this video here, and I will make some other clips with the worked examples. Okay, thank you.